done with the characteristics of hazards, we're going to move on to hazards again, but more specifically, hazard event prediction. And in the syllabus, this is dedicated 3 hours, and the assessment objective or the objective of the video would be to examine the methods used to make estimates or predictions of the probability in time and space of hazard events occurring, and of their potential impact on lives and property, and to discuss these methods by examining case studies relating to 2 different hazard types. So let's get right into it. We're talking about this today because a crucial part of reducing the potential impact of a hazard event on lives and property is being able to predict when and where a hazard event will take place, and if not, to be able to at least have some idea of the probability of being affected by a hazard event and its possible magnitude. Of course, knowing when a hazard event will take place with enough time will allow people to prepare for it, either by gathering necessary resources, improving their own homes for protection, moving to a safer place in their area, or even time to evacuate the area altogether to avoid the hazard event. Clearly, having this time is critical in minimizing the damage done to lives or their property by a hazard event. First, let's talk about predicting a hurricane. They are very difficult to predict. However, certain patterns are visible in their creation and movement. While we can't predict exactly where a hurricane will form, we can forecast its path once it has formed. So, either satellites can detect hurricanes in their early stages of development. First, we'll talk about predicting hurricanes. Now, due to the complex nature of our atmospheric system, they are very difficult, if not impossible, to predict a hurricane. However, certain patterns are visible in where they originate and where they move to. Once a hurricane has formed, it initially moves westward and slightly towards the poles, picking up speed as it does so. And due to the conditions necessary for a hurricane to occur, we know that they form generally between 5 and 30 degrees latitude, either north or south. Hurricanes also typically die out as soon as they leave the tropics or go over a substantial landmass. Hurricanes also generally occur within a specific season, known as hurricane season. This is July to October in places like the Atlantic, Eastern Pacific, and Western Pacific north of the equator, as well, and it is November to March in the Indian Ocean and off of Australia. Satellites are also a very useful tool when it comes to predicting hurricanes, as since they are in space, they have a pretty good vantage point, and they can detect hurricanes in their early stages of development, providing a timely warning for nearby people. In terms of potential impact, the Saffir-Simpson scale is useful to estimate potential property damage of hurricanes. Now, moving on from hurricanes and onto earthquakes. When it comes to predicting an earthquake, it is much like predicting a hurricane, as the earthquake occurs in predictable areas, and that is along the tectonic plate boundary. The hard part is to determine when the plates will shift and release the energy that is accumulated to create the earthquake. No one is really capable of forecasting precisely when an earthquake will occur. Now, partly because they are underground, it is difficult to measure or directly observe when a hurricane will occur. However, the most reliable methods are measuring and monitoring small-scale ground surface changes such as ground uplift and tilt, which are a result of the swelling of the rocks while they accumulate pressure at the fault, measuring changes in rock stress, monitoring micro-earthquake activity, reading on magnetic field anomalies, measuring changes in radon gas concentrations, and changes in electrical sensitivity of rocks. Again, it is very difficult to reliably predict when an earthquake will happen, and as a testament to that, there's a case study from Parkfield, California, which is located on the San Andreas Fault. Because this is such an earthquake-prone area, it was heavily equipped with geological instruments to be able to see when or try to predict when an earthquake would happen. While the scientists could predict some earthquakes to a certain degree of accuracy, many earthquakes still took them by surprise, and it turns out it is due to our current lack of geological knowledge. It turns out that many earthquakes would occur in faults that scientists were not even aware of. This shows that we are probably very far away from being able to accurately and consistently predict when and where an earthquake will happen. While we can't predict accurately when an earthquake will happen, we're quite familiar with the areas that are prone to earthquake activity. This means that in an attempt to reduce potential damage, we can choose not to build or live there, or even design structures specifically to better resist earthquakes. Predicting hazards is not easy or even entirely possible. However, being aware of the possibility of a hazard event and its effects, in other words, the risk, helps us be prepared for hazard events or to avoid them when necessary. Thank you very much for watching. I think we'll move on from hazards and disasters for now and move on to the geography of food and health in the next video.